The Earth is ancient, 4.5 billion years old, and yet our story, the story of civilization, has lasted barely a heartbeat in that vast span of time. We believe ourselves to be the first, the only. But what if we are wrong? Imagine this planet not as a home, but as a stage upon which countless dramas have unfolded. Oceans rising, continents shattering, species flourishing and vanishing. Again and again, the curtain falls, leaving almost nothing behind. 99% of species that ever lived are gone, their fossils rare, their memories erased. Entire mountain ranges have risen and crumbled to dust. Oceans have swallowed continents, carrying whole worlds into darkness. If time can erase so much, what else might it have hidden? In 2018, two scientists asked a question that sent ripples through the scientific world. What if Earth once hosted another industrial civilization millions of years before us? A civilization erased so completely its only traces lie buried in the chemistry of stone. They called it the Silurian Hypothesis. Could it be possible that long before humanity, others walked this earth? Creatures with knowledge, with tools, with dreams, gone without a trace. If so, how would we ever know? This is not just a question of science. It is a question of memory, of how much a planet can remember, and how much it can forget tonight. We travel into deep time to uncover whether humanity is truly the first civilization on Earth, or only the latest chapter in a story far older and far stranger than we dare imagine.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
In the year 2018, two scientists, Gavin Schmidt, a climatologist at NASA, and Adam Frank, an astrophysicist at the University of Rochester, proposed a question that sounded more like a riddle than a formal hypothesis. What if humanity was not Earth's first industrial civilization? They called it the Silurian Hypothesis, a thought experiment designed not to prove hidden empires in the deep past, but to test the very limits of how detectable our own existence would be millions of years from now. The name was borrowed from an unlikely source, science fiction. In the 1970s, a British television program imagined an ancient race of reptilian beings that ruled the Earth long before humans, creatures that went into hibernation beneath the crust, only to awaken in the present. Schmidt and Frank adopted the term with a touch of irony, but their question was entirely serious. Could the rocks beneath our feet conceal the ghosts of an advanced species, erased by time, yet written faintly in stone? The Silurian period, stretching back more than 400 million years, was chosen symbolically. It was the age when complex life first began to take confident steps onto land, when plants reached upward in forests of unfamiliar design, and when the seas were filled with armored fish and early coral reefs. No humans, no mammals, not even the dinosaurs yet, but a flourishing of ecosystems that hinted at what Earth could nurture. If an advanced species had arisen then, its traces would now be buried beneath epochs of shifting continents and relentless geology. The Earth keeps its history in layers, like the pages of an ancient diary. Fossils pressed into stone, isotopes scattered like signatures in mineral veins, sediment cores drilled from the ocean floor. Each tells a story, but always an incomplete one. For every fossil discovered, countless others have been crushed, melted, or recycled back into magma. It is estimated that 99% of all species that ever lived are gone, vanished not only in life, but in evidence. The record we study is not a library, but a fragment of one, a few surviving pages of a book, billions of years long. This is where the challenge of deep time reveals itself. Entire mountain ranges rise and vanish, oceans open and close, continents split and collide. In less than 10 million years, most surface traces are erased. Buildings, roads, even entire cities would be swallowed by the shifting plates of the planet. After 100 million years, even the most enduring human structures would be ground into dust, indistinguishable from the rocks that replaced them. If humanity's legacy is so fragile, then what chance does a hypothetical civilization from the Silurian period stand? Yet Earth does leave clues, not in monuments, but in chemistry. Geological eras have been scarred by sudden, violent transformations, rapid climate shifts, mass extinctions, and strange anomalies in the carbon cycle. These events stand out like signatures in the otherwise steady rhythm of deep time. The Paleocene thermal maximum, about 56 million years ago, was one such anomaly. Carbon levels spiked, temperatures soared, oceans grew acidic, and ecosystems collapsed. To modern eyes, these signatures resemble the planetary scars our own industrial age is carving today. Could such events be natural, driven by volcanic eruptions, asteroid strikes, or methane releases? Almost certainly. But Schmidt and Frank asked, what if, in some far-flung epoch, they were not? What if the Earth, long before our arrival, had already endured the consequences of an earlier industrial species, one that burned fuels, altered climates, and then disappeared, leaving only the chemical echoes of its rise and fall? The suspicion is unsettling, but also subtle. Modern science has indeed uncovered isotope levels that seem strange, extinction patterns that seem abrupt, and carbon spikes that echo human fingerprints. Yet the evidence can always be explained by natural forces. Asteroid impacts, continental rifting, flood basalt eruptions, all powerful enough to mimic the kind of planetary change industry might cause. And so the record whispers, but never shouts. Long before Schmidt and Frank formalized the idea, echoes of lost civilizations had haunted human imagination. Myths of Atlantis, Lemuria, or ancient kingdoms drowned beneath the sea have persisted for millennia. Some were allegories, some born of mistranslation, others pure invention. But all carried the same haunting suggestion, that we are not the first. The difference now is that science entertains the question with data, not legend, using geology instead of myth, isotopes instead of stories. Thus, the discovery phase begins, not with ruins or artifacts, but with questions scratched into stone by time itself. Questions that blur the boundary between imagination and science. If a civilization once walked the earth in the Silurian age, would we recognize its signature, or would it dissolve into the background noise of natural catastrophe? If humanity is destined to be forgotten in similar fashion, what will the earth look like 100 million years from now, when our own chapter is reduced to a single line in the rocks? The Silurian Hypothesis does not claim such a civilization ever existed. Instead, it reminds us that the search for evidence is fragile, limited, and fleeting, that even in our own Anthropocene, the mark we leave behind may be less permanent than we think. In this realization lies the true mystery, not whether we are alone in time, but whether the Earth itself is capable of remembering any of its civilizations at all. The Silurian Hypothesis begins as a question, but as the implications unfold, it transforms into a shockwave that unsettles the foundations of science itself. The first jolt comes from the realization of absence. Archaeology, paleontology, and geology rely on visible traces, artifacts, bones, ruins. Yet time is an unforgiving eraser. A human-made city, if abandoned today, would be overtaken by nature in centuries, its concrete cracked, its steel corroded. In 10,000 years, little would remain but faint imprints in soil. In 1,000,000 years, even those would fade into geological silence. And after 10 million years, tectonic movement, erosion, and sedimentation would bury all recognition. After 100 million years, our greatest monuments would be untraceable. This is the first shock, that absence of evidence is not evidence of absence. A civilization separated from us by 100 million years could vanish so thoroughly that its very possibility seems absurd. And yet, the Earth's record is not empty. It is filled with scars. Scientists ask, if there were predecessors, what should we be looking for? The answer is not statues or temples, but technosignatures written into the chemistry of rocks and oceans. Consider plastics. Our world is saturated with them, polymers that never existed in nature before us. They degrade slowly, fragmenting into microplastics carried by rivers, winds, and seas. Even if all visible forms disappeared, their chemical fingerprints would persist in sediments. Future geologists could find plastic residues compressed into stone, a strange stratum distinct from all before it. Could an ancient civilization have left its own version of such markers, molecules unlike anything made by natural processes? Carbon isotopes offer another signature. Today, humanity burns fossil fuels that are tens of millions of years old, releasing carbon-12-enriched gases into the atmosphere. This shift alters the ratio of carbon isotopes preserved in ocean sediments, creating a spike, a sudden deviation, unlike the gradual rhythms of natural cycles. Scientists call this the Swiss effect. If we left the planet tomorrow, this fingerprint would endure long after our cities crumbled. And if a prior civilization had burned fuels or released similar emissions, the same isotopic anomalies might exist, buried in ancient stone. Then there is radioactivity. Since the mid-20th century, human nuclear activity has scattered artificial isotopes, plutonium, cesium, strontium, across the globe. Substances that do not occur naturally, but which can persist for hundreds of thousands of years. If discovered in deep time, they would be undeniable evidence of technological industry. But what if others, long before us, had split atoms in their own era? Would we recognize the traces or dismiss them as unexplained anomalies? Here lies the unsettling core of the hypothesis. Even if ancient technosignatures exist, Earth's record may disguise them as natural events. A massive carbon release could be the aftermath of volcanism, or it could be the echo of combustion engines. A sharp radioactive anomaly could point to asteroid impacts that scattered unusual isotopes, or to the shadow of ancient reactors. The second shock is philosophical. If the signs of our own civilization could be mistaken for natural disaster, how can we trust our reading of deep time? When geologists study extinction events, they interpret them as products of nature. Supervolcanoes, asteroid strikes, or runaway methane releases. But could even one of these events be anthropogenic? Not ours, but theirs. The thought unsettles, not because it is proven, but because it cannot be fully ruled out. The Earth's most violent transitions illustrate this problem with eerie clarity. The Permian-Triassic extinction, 252 million years ago, wiped out more than 90% of marine species and 70% of land vertebrates. Carbon dioxide levels surged, oceans turned acidic, temperatures spiked by as much as 10 degrees. The accepted cause is the Siberian traps, vast volcanic eruptions that released unimaginable quantities of carbon. Yet to a planetary scientist in another galaxy, observing only the chemical aftermath, the event might look strikingly similar to what humans are producing now. Another example lies in the Paleocene thermal maximum 56 million years ago. Carbon levels doubled, global temperatures rose by 5 to 8 degrees, polar regions became lush with subtropical flora, and deep oceans turned hypoxic. The event lasted around 200,000 years, then ended. Our current trajectory echoes this ancient episode, unfolding on a timescale thousands of times faster. Could that earlier spike have been purely geological? Almost certainly, but the similarity stirs unease, for it shows how the Earth remembers change, yet forgets causes. Scientists speak cautiously here. The Silurian hypothesis is not embraced as evidence of secret civilizations, but as a test of humility. It forces us to confront the fragility of our own record, to imagine how alien archaeologists, millions of years in the future, would judge our brief Anthropocene, and how easily they might misinterpret it. The third shock is cosmic. If it is so difficult to prove whether an industrial civilization existed on Earth, so on surface with its relatively accessible record, then what of exoplanets, light years away? Astronomers seek technosignatures in distant atmospheres, chemical imbalances that betray artificial activity. But if our own civilization can be hidden in the rocks of our own planet, how could we expect to detect others across the stars? Thus, the Silurian hypothesis expands beyond Earth, becoming part of the Fermi paradox. The silence of the stars may not prove the absence of civilizations. It may only prove that civilizations are buried, erased by time, masked by nature, or hidden by their own fragility. The shock lies not in the suggestion that we had predecessors, but in the realization that we might never know, even if they did exist. Evidence may be there, but indistinguishable from the roar of volcanism and the scars of impacts. The Earth's record whispers, but the language is too easily confused. And so, science faces a mirror. Humanity believes itself the first, yet can prove neither its uniqueness nor its permanence. The Silurian hypothesis is less about confirming ancient civilizations than about questioning the arrogance of certainty. It reminds us that deep time is vast, merciless, and deceptive, that even in science, silence does not mean nothing happened. This is the scientific shock, that the Earth may have forgotten more than it remembers, and that in forgetting, it may have erased whole worlds before our own. The shock of the Silurian hypothesis lingers. But science demands more than provocation. It requires the careful search for evidence, hidden not in myths or speculation, but in the silent archives of the Earth itself. If a prior industrial civilization once thrived, its footprints would not be found in temples or statues. Instead, the traces would lie in chemistry, in isotopes locked within stone, in the sediments of oceans, in the molecular fossils of air long gone. And so the investigation deepens. Scientists turn their attention to Earth's greatest cataclysms, moments when life itself teetered on the brink, when the climate shifted violently, and when ecosystems collapsed. If anywhere a technosignature might be mistaken for natural disaster, it is here in the scars of extinction. One such scar is the Permian-Triassic extinction, the Great Dying, around 252 million years ago. More than 90% of marine species vanished, along with 70% of terrestrial vertebrates. Carbon dioxide levels soared, global temperatures rose sharply, and the oceans lost most of their oxygen. The prevailing explanation is vast volcanic activity in what is now Siberia, eruptions that lasted hundreds of thousands of years, releasing unimaginable quantities of greenhouse gases. Yet, in chemical terms, the fingerprints of this event bear uncanny resemblance to industrial emissions. Sharp carbon isotope anomalies, rapid acidification, and a spike in extinction. The pattern mirrors, in slow motion, what humans are now producing in fast forward. Another scar emerges at the Paleocene thermal maximum, 56 million years ago. Here, in a geologic instant, the world warmed by up to 8 degrees Celsius. Ice vanished, polar forests thrived, and deep oceans turned hypoxic. The carbon spike preserved in sediments is among the sharpest ever recorded. The standard explanation invokes methane hydrates released from seafloors or massive volcanic intrusions into carbon-rich rocks. But the chemical signature, a sudden flood of carbon wealth into the system, could, in theory, resemble the aftermath of fossil fuel combustion. To imagine this as an industrial echo is speculative, yet the resemblance cannot be ignored. Beyond extinctions, other anomalies trouble the geological record. Layers rich in iridium, usually explained by asteroid impacts. Sudden bursts of unusual isotopes, like mercury, often linked to volcanic activity. Massive deposits of coal and oil that hint at ancient biomass crises. Each has a natural explanation, yet each, under the Silurian Hypothesis, becomes a candidate for reinterpretation, not proof, but possibility. The search then turns microscopic. Within sediments lie molecular fossils, traces of compounds that resist decay. Plastics, for example, leave residues of synthetic polymers, broken into fragments, too small to see, but preserved in stone. If humanity vanished, microplastics would persist for millions of years, embedded in clays, sands, and marine sediments. Could earlier civilizations have produced their own version, polymers, composites, or exotic molecules unknown to natural chemistry? If so, their residues might still lie beneath our feet, cataloged by geology, but never recognized as artificial. Isotopes tell another story. Today, the burning of fossil fuels is altering the ratio of carbon-12 to carbon-13 in the atmosphere, a signal etched into the chemistry of shells, corals, and sediments. This Swiss effect will endure long after our machines fall silent. Likewise, nitrogen isotopes shift under the influence of synthetic fertilizers, a signature preserved in soils and aquatic systems. If discovered millions of years hence, these anomalies would reveal the hand of industry. Could similar signatures from long ago, already noted by geologists, represent forgotten predecessors rather than natural flux? Ocean sediments are perhaps the most faithful archivists of planetary change. Layer by layer, they capture the fall of dust, the rain of organic matter, the wash of chemicals from continents. Drilling projects like the Deep Sea Drilling Program and the Integrated Ocean Drilling Program have extracted cores that span tens of millions of years. Within them lie spikes of carbon, traces of oxygen fluctuations, and the fingerprints of catastrophic warming events. Each is studied as climate history, but each is also a potential archive of technosignatures, and yet the record is never complete. Sediments erode, cores are interrupted, entire spans of millions of years are missing. Earth's diary is torn, with chapters ripped away by tectonics and time. What remains are fragments, requiring interpretation. And interpretation is the very space where uncertainty breeds. Some scientists suggest that if the Silurian hypothesis were true, we may already have overlooked its evidence, because natural processes can mimic industrial signatures. Anomalies are explained by volcanism, methane release, or impacts. But what if, buried within these explanations, lies a story we have not yet imagined? A civilization mistaken for a volcano, a technological age disguised as flood basalt. The absence of direct artifacts intensifies the mystery. Tools, structures, and bones do not survive beyond a few million years. Even fossilization is rare, requiring precise conditions of burial and mineralization. 99% of species vanish without a fossil record. If humanity were erased tomorrow, perhaps only scattered bones, rare artifacts, and isotopic scars would remain compressed beneath future mountains. For a civilization hundreds of millions of years older, even that would be gone. The deeper investigation then expands to methodology. How do scientists detect past industrial signatures with rigor without leaping into speculation? They analyze isotope ratios in carbon, oxygen, and nitrogen. They study trace elements like mercury and iridium. They map temperature spikes and extinction rates. They test for sudden bursts of synthetic-like compounds in ancient clays. Each approach builds a case, not for civilizations, but for patterns, and patterns once found may invite reinterpretation. Perhaps the most unsettling realization is that humanity itself may one day be misclassified. Millions of years in the future, the Anthropocene layer may look like a rapid climate anomaly. Our plastics, our isotopic scars, our radionuclides may blur into the noise of volcanism and impact. Future scientists, human or otherwise, may read our existence as a curious warming event, nothing more. If so, then how many times before has Earth whispered the same story, misread and forgotten? The Silurian hypothesis does not claim certainty. It claims possibility. It suggests that science, in its caution, may miss what it is not trained to see. That the line between natural and artificial in deep time may not be as sharp as we imagine. And so the investigation continues, probing extinction events, anomalies, and molecular fossils. Not in search of Atlantis or myth, but in search of humility. The humility to admit that the Earth may keep secrets far older than ourselves. The deeper we dig, the more the ground itself seems to whisper. Civilization may not be a singular occurrence, but a recurring tide, rising, falling, and erasing itself with every cycle of time. The deeper the investigation goes, the heavier the silence becomes. For every anomaly explained away by volcanism, every isotopic scar assigned to methane or asteroid impact, one truth remains unshaken. The Earth is vast enough, old enough, and merciless enough to erase almost anything. even civilizations. This realization shifts the Silurian hypothesis from curiosity into something darker. If evidence can vanish so easily, how can we be certain of our own permanence? What if, in deep time, the story of humanity becomes nothing more than a geological whisper, indistinguishable from the roar of natural catastrophe? Civilizations seem immense to themselves, towers stretching skyward, satellites orbiting the Earth, machines reshaping landscapes. Yet measured against geological time, they are as fragile as frost on glass. The entire history of industrial humanity, from coal furnaces to digital age, spans barely 3 centuries, a blink so brief it is invisible in stratigraphic layers. A single line of dust, a flicker of isotopes, icily misread. This is where the mystery deepens. For if Earth forgets so quickly, then how many forgotten worlds might already lie beneath our feet? How many times has intelligence bloomed, burned brightly, and then collapsed into silence, each cycle leaving less behind than the one before, until memory itself becomes impossible? Consider the abyss of missing chapters in the fossil record. Between great extinctions, entire worlds rose and fell, ecosystems flourished and vanished, yet little remains but fragments. To imagine a civilization erased in the same way is no longer impossible. It is inevitable. The escalation also comes from Earth's own violence. Continents drift and collide, mountains rise and erode, oceans open and close. In less than 200 million years, every surface feature we know today will be gone, subducted into the mantle, recycled as new crust. Even if humanity carved mountains into statues, they would not endure. The Earth is not a museum. It is a recycler, endlessly reshaping itself. And then comes the most unsettling reflection. If we struggle to detect a civilization on our own planet, what chance do we have beyond Earth? We search the stars for signals, for atmospheric anomalies, for distant technosignatures. Yet the lesson here is humbling. Civilizations may vanish so completely that their existence becomes undetectable. Not because they never were, but because time devours all proof. This echoes into the silence of the Fermi paradox. Why do we not see them? The countless civilizations that should exist in a galaxy of billions of stars. Perhaps the answer is not that they never existed, but that they vanish quickly, leaving only scars that blend into nature. A silence not of absence, but of forgetting. The deepening mystery reshapes our understanding of humanity itself. We are not the inevitable pinnacle of life, but a fragile experiment, balanced on geological scales we scarcely comprehend. Our Anthropocene is not the first age to scar the Earth, and it may not be the last. Civilizations may be as natural as ice ages, as temporary as coral reefs, as cyclical as tides. Yet there is terror in this thought. For if civilizations are cycles, then collapse is not an accident, but a pattern. Intelligence may carry within it the seeds of its own erasure. Industrial expansion, planetary destabilization, climate catastrophe, the very forces that allow a species to rise may ensure its destruction. This is where the Silurian hypothesis moves beyond speculation into warning. We see our own reflection in deep time, a glimpse of what might await us. If Earth has hosted forgotten civilizations before, then it has also destroyed them. And if we are the first, then we are still bound to the same erasing forces that will one day reduce us to silence. Philosophers describe this as the abyss of recurrence. the haunting possibility that intelligence, no matter where it appears, is doomed to rise, burn, collapse, and vanish over and over again. Not eternal empires, but fleeting sparks in a cosmic night, and the abyss deepens when we extend our gaze outward. If Earth can forget, then so can Mars, Venus, or any exoplanet. Mars once had rivers and seas, a climate stable enough to host life. If a civilization arose there billions of years ago, what would remain now? Windswept deserts, buried layers, nothing more. Venus may once have been habitable, its oceans boiling away in a runaway greenhouse. If intelligence bloomed, its traces would now lie beneath crushing heat and clouds of acid. We look outward and see silence, but perhaps the silence is only the echo of forgetting. Back on Earth, the escalation takes on a more personal tone. The very signs we search for in deep time are the ones we are now creating ourselves. Plastics in sediments, carbon isotope anomalies, radioactive dust. These are our techno-signatures, our legacy. And yet, as we realize their fragility, they become ghostly, fragile threads, easily unraveled by the hand of time. This realization turns the hypothesis inward. It is no longer about whether others once existed, but whether we will leave anything behind at all. Humanity measures its triumphs in monuments, technologies, and records. But in the view of deep time, our greatest libraries may be erased as though they never were. Our cities may dissolve, our satellites may fall, and our memory may vanish. Civilization itself may be less permanent than the fossils of trilobites or the coral skeletons of forgotten seas. The mystery deepens, not only in science, but in meaning. For if the Earth forgets all civilizations, then what is civilization? A performance without audience, a story written in disappearing ink, a dream the Earth wakes from, leaving no trace of the dreamer. And yet, within this darkness lies a strange beauty. The knowledge that we may not be alone in time, even if we cannot prove it. That others may have walked, built, dreamed, and vanished just as we will. That civilizations, like stars, may be born, flare, and die, each leaving a trace too faint for the universe to keep. Thus, the mystery escalates, from geology to philosophy, from silence to warning, from science to reflection. Humanity stands at the edge of deep time, peering into an abyss that does not answer back. And in that silence, the greatest question of all grows louder. Were we truly the first, or are we only the latest chapter in a book the Earth keeps writing, then erasing, page after page? Speculation is the oxygen of mystery, and the Silurian hypothesis thrives on it. If science admits the possibility that Earth may have hosted civilizations before us, then imagination steps forward to ask, what kind of civilizations might they have been? What forms of intelligence could have risen, thrived, and vanished long before our kind? The first path of speculation leads to the land. In the Silurian period, hundreds of millions of years ago, life was already complex. Armored fish swam in ancient seas, early forests climbed skyward, and strange arthropods scuttled across shallow shores. No mammals yet, no birds, no flowering plants, yet niches for intelligence existed. Evolution does not preordain humans, it only experiments endlessly. Could a lineage of reptilian beings or amphibious hunters have evolved higher cognition? Their bodies would leave fossils no different from countless others, their tools long dissolved, their cities swallowed by tectonics. The idea of reptilian intelligence is not only myth, it is biology's open possibility. Dinosaurs themselves, tens of millions of years later, reigned for 160 million years, far longer than humans have existed. Among them, some paleontologists once imagined a dinosauroid path, a hypothetical evolution where small, intelligent theropods developed larger brains, dexterous limbs, and advanced societies. None did, as far as we know, but the possibility lingers as a mirror of what might have been and what could have been erased. Another path leads to the oceans. Most of Earth's surface has always been water, and the seas are fertile with intelligence. Octopuses, dolphins, whales, all show signs of advanced cognition today, but their civilizations are limited not by intelligence, but by environment. Tools corrode underwater, fire is impossible, written language difficult. Yet, what if, in earlier epochs, another lineage of marine intelligence had found ways we cannot imagine? An aquatic civilization may leave fewer traces than any land-based one. Its artifacts lost in sediments, its signatures erased in oceanic churn. To detect it millions of years later would be nearly impossible. Speculation expands further when we ask not just what they were, but how they lived. Would they have burned fuels as we do, leaving carbon spikes? Or might they have harnessed energy differently? Geothermal power from volcanic vents, tidal energy, even biochemical methods beyond our imagining. If so, their industrial layer may not resemble ours. It may leave no carbon anomaly, no plastics, no radioactive isotopes. Their technosignatures might have blended seamlessly into nature, invisible to our current tools. But if they did use fossil fuels, the record may already hold their scars. The isotope spikes we see at the Paleocene, thermal maximum, or the Permian extinction could be echoes of their combustion, indistinguishable from volcanism to us, but not to them. If they had nuclear energy, artificial isotopes could have been scattered, but over hundreds of millions of years, decay would erase most evidence, leaving only faint anomalies too subtle for current instruments. Speculation also entertains alternate trajectories of science itself. Humanity developed electronics, metals, and computation, but intelligence is not bound to the same path. Another civilization might have mastered biology instead of machinery, weaving living organisms into tools and structures. Their legacy would be even more fragile. Organic cities, biological technology, tools that decayed back into soil, leaving almost nothing behind. A civilization made of life itself might vanish as completely as any forest. Others may have pursued chemistry or acoustics, mastering forms of knowledge unrelated to our inventions. They may have lived in harmony with ecosystems, leaving minimal impact and thus minimal trace. Civilizations like these would rise, flourish, and dissolve without leaving scars visible millions of years later. In such a case, the Silurian hypothesis becomes even more haunting, for absence of evidence may not mean absence of civilization, but only the presence of one too subtle to find. Theories stretch outward as well. Some imagine cycles, civilizations rising repeatedly on Earth, each destroyed by the same forces: climate destabilization, asteroid impacts, self-destruction. If so, we are not unique, but participants in an ancient rhythm bound to repeat until the cycle ends. This theory ties the Silurian hypothesis to the concept of the Great Filter, the idea that civilizations, wherever they arise in the universe, encounter barriers that prevent permanence. Perhaps the Great Filter is not ahead of us, but behind us, repeated countless times on Earth alone. Another speculation blends myth with geology. Atlantis, Lemuria, and countless cultural legends speak of ancient, advanced societies lost beneath oceans or destroyed by catastrophe. While archaeology finds no evidence within human history, the Silurian hypothesis allows perhaps the persistence of these myths is not coincidence, but cultural echoes of something older, a faint memory of cycles long before humanity passed through symbolic imagination, disguised as legend. Science cannot prove this, but neither can it dismiss the universal human intuition of civilizations lost to time. The speculation grows more provocative when extended beyond Earth. If we cannot prove or disprove forgotten civilizations here, what of Mars? Billions of years ago, Mars had rivers, lakes, perhaps oceans. Its atmosphere was thicker, its climate more stable. If life arose there, could intelligence have followed? If so, its traces would now lie buried beneath dust and ice, indistinguishable from geology. We search Mars for microbial fossils, but what if we are walking past eroded ruins, too ancient to recognize? Venus too once held oceans, perhaps for billions of years, before a runaway greenhouse transformed it into a furnace. If life evolved there, intelligence might have followed, but its evidence would be buried under miles of volcanic rock, melted by heat and erased. The lesson returns. Even planetary civilizations may be forgotten, their memory buried beneath geology. Speculation also extends to exoplanets. Astronomers search for biosignatures and technosignatures in distant atmospheres, unusual gas mixtures, industrial byproducts, or energy use. But the Silurian hypothesis warns us. Even if a planet once hosted civilization, millions of years later, it may appear empty, its signs erased. The silence of space may not be absence, but amnesia. Theories even reach into philosophy. Perhaps civilizations are not meant to endure. Intelligence may be self-extinguishing, its very success leading to overuse of resources, destabilization of climate, collapse of ecosystems. Our industrial age, brief though it is, already shows such tendencies. If this is universal, then civilizations may burn out quickly, leaving little trace. If so, we should not expect to find evidence of predecessors. Their memory is erased as swiftly as ours may one day be. Another speculative thread asks, what if intelligence itself is common, but visible technology is rare? Perhaps most civilizations do not pursue industry as we define it. Perhaps they evolve spiritual, social, or biological complexity without machines. Such civilizations would leave almost no geological scars. Their traces would vanish even faster, dissolving like shadows in stone. And yet, despite this vastness of speculation, one thread remains constant. Whether on Earth or elsewhere, whether reptilian, mammalian, or aquatic, whether industrial or biological, all civilizations face the same adversary: time. Time erases, time buries. Time reduces even the grandest cities to dust and memory. The Silurian hypothesis, in this light, becomes less about proving ancient predecessors and more about humility. It asks us to imagine that we are not the first, and therefore we may not be the last. It forces us to see intelligence as transient, fragile, and cyclical, not a destiny, but a passing experiment. Speculation does not provide answers. It opens doors into silence. It offers mirrors, in which we see not only what might have been, but what may come. It is unsettling because it suggests that Earth may have forgotten entire worlds, and that we too may be forgotten, joining them in the deep library of erased civilizations. And yet, in this silence, there is wonder. For even if civilizations rise and fall unremembered, the universe still knows them, if only for a moment. And in that moment, they burned bright, as we do now. Theories must be tested, evidence must be sought, and mysteries must be confronted with tools. If the Silurian hypothesis is to be taken seriously, then geologists, climatologists, and planetary scientists must ask, what instruments could reveal traces of civilizations long vanished? These sediments, compressed into cores by drilling projects, act as the planet's black box recorder. They preserve chemical traces of atmosphere, climate, and catastrophe. Within them lie carbon isotope ratios, oxygen fluctuations, and residues of ancient life. If any industrial activity scarred the Earth before us, its signature may be pressed into these cores, waiting to be read. One of the most powerful tools is isotope geochemistry. Nitrogen isotopes reveal patterns of fertilizer use and biospheric disruption. Oxygen isotopes record temperatures locked in shells and sediments. Mercury, for example, often spikes during massive volcanic eruptions, but could also be released industrially. Iridium, rare on Earth's surface, is famous as the marker of the asteroid that ended the age of dinosaurs. These elements are the cryptic language of geology, and each anomaly is a clue. Plastics, though modern, offer a lesson. Already, microplastics have been found in sediments across the globe, from polar ice to deep-sea trenches. They are a new fossil of the Anthropocene. And so, scientists ask, if such synthetic residues exist in ancient rocks, would we even recognize them? Or would we classify them as oddities of geology? These isotopes decay on timescales of thousands to millions of years. If found in deep strata, they would be unambiguous evidence of technological activity. Scientists search for such anomalies, though so far none beyond human activity have been detected. For the Silurian hypothesis is not only about Earth, it is about civilization as a planetary phenomenon. If we struggle to detect our own industrial traces here, how can we expect to recognize them on exoplanets light-years away? It can detect gases like methane, carbon dioxide, ozone, biosignatures that hint at life. But it can also, in theory, detect technosignatures, chemical imbalances that cannot be explained by biology alone. SETI, once focused only on radio signals, now broadens its scope. Instead of listening only for transmissions, scientists also search for planetary-scale changes, waste heat, artificial illumination, or chemical residues. By asking what traces our own civilization leaves behind, we learn what to seek elsewhere. And in doing so, we also realize how fragile those traces may be. Future tools may sharpen this search further. AI-driven analysis of geological cores could detect subtle anomalies overlooked by humans. But even with these tools, a sobering truth emerges. The longer the timescale, the fainter the signal. After hundreds of millions, continents recycle themselves through subduction. The possibility of detection shrinks to almost nothing. And yet, science persists in the search, because even a faint chance of discovery could reshape our understanding of life, intelligence, and time. It forces scientists to confront the silence of the geological record with sharper instruments, deeper cores, and more open minds. Perhaps one day a core sample will reveal a chemical fingerprint that defies natural explanation. Perhaps a telescope will detect artificial gases in the skies of a distant world. Or perhaps nothing will ever be found, and the Earth's silence will remain unbroken. In each case, the tools sharpen the question, even if they never deliver the answer. And so, science continues its quiet excavation, drilling deeper, analyzing finer, scanning further, not in pursuit of certainty, but in pursuit of possibility. For even if Earth has forgotten, even if the rocks remain silent, the act of looking changes how we see ourselves. It reminds us that our civilization is both immense and fragile, that our memory may one day be no more permanent than dust. The Silurian Hypothesis lives not only in speculation, but in the instruments we wield. For in searching for others, we measure the endurance of ourselves. The search for forgotten civilizations begins in science, but it ends in silence. For even after isotopes are measured, sediments are drilled, and anomalies are catalogued, the question remains unanswered. Were we Earth's first, or simply its most recent? Philosophy steps into the void left by geology, and whispers a truth both humbling and haunting. Civilizations are not immortal. They are temporary patterns, brief sparks in the vast night of time. The Earth has endured for 4.5 billion years. Humanity's industrial age has lasted for just 3 centuries, an instant already fading as it is lived. If others once walked this world, their memory is gone, their monuments recycled into stone, their voices erased by oceans, their signatures dissolved into the churn of the planet. And if this is their fate, then it will also be ours. For no matter how high our towers, how vast our networks, or how loud our machines, the Earth will one day forget us too. This realization reshapes the way we see ourselves. Civilization becomes not a permanent achievement, but a fragile performance on the stage of deep time. We are guests, not masters, fleeting visitors in a universe that keeps no records beyond the stars. Yet within this fragility lies meaning. For if we are temporary, then every moment matters more. Every discovery, every dream, every act of creation is part of a brief but brilliant fire. We may be forgotten, but while we endure, we burn. The Silurian Hypothesis is not only a question of science, it is a mirror. It reflects our fears of being forgotten, our hope of being unique, our longing to matter in a cosmos that does not remember. Whether or not others came before us, the truth it reveals is the same. That the measure of a civilization is not how long it endures, but what it becomes in the time it is given. Perhaps civilizations are like waves upon the ocean, rising, breaking, and dissolving, only for another to follow. None permanent, none eternal, yet each part of a rhythm older than memory. Perhaps intelligence itself is not a destination, but a cycle, destined to bloom, vanish, and bloom again. And perhaps this is not tragic, but beautiful. For even if the Earth forgets, the universe remembers in its own way. Every civilization is a ripple in space-time, a unique arrangement of matter and thought that existed, however briefly. To live, to think, to build, to wonder. These are miracles, even if they vanish. As this reflection draws to a close, one truth remains. Humanity may not be the first, and it will not be the last. But in our fleeting moment, we can look back and forward. We can wonder about what has been and what may come. And in that act of wonder, we become eternal, if only in our own hearts. The earth may erase civilizations, but the stars cannot erase. EOE. And awe is the one trace that endures within us, and perhaps within all who come after. And so, as the silence of deep time surrounds us, we leave you with a reminder. The mysteries of the cosmos are endless, and the stories of forgotten worlds are still being written in stone. If you wish to keep exploring these mysteries, if you wish to keep journeying through space, time, and the unknown with us, do not forget to subscribe. Whisper Science will be your companion in this endless search for meaning, in a universe that always remembers through wonder.